Okay, ladies and gentlemen, this video homework is comparing and contrasting ionic and covalent bonds. We've spent most of our time so far on ionic bonds. Covalent bonds is another beast. So we're going to do two columns. We're going to do a column for ionic bonds, and we're going to do a column for covalent bonds. So line down the middle. Okay. Now, for both of these, the goal for both of them is a full outer energy level. Full outer energy level. Full outer ring of electrons. But how they do it is different for the two. In ionic bonds, we have electrons are given or taken. And this forms ions, which are charged particles. For example, oxygen with 6 valence electrons wants 2 more. It wants to gain 2 electrons to form a -2 charge. With covalent bonds, the electrons aren't given or taken, but the electrons are shared. Shared between the atoms. There's no ions. So with ionic bonds, the elements are held together by static electricity, by the attraction of positive and negative charges. By static charges. So if I have sodium, which wants to give away an electron, and chlorine, which wants to take an electron, I have a positive, I have a negative. You can't see that. There we go. I have a positive, I have a negative. They want to get together. Covalent bonds, the atoms are held together by the shared electrons. You have it for a little while, then I'll have it for a little while. Atoms held together by shared electrons. By those mutual electrons. I'll take it, you take it, we'll stay together and pass it back and forth. Ionic compounds form between a metal and a non-metal. But covalent bonds are between non-metal and non-metal. Non-metal, horrible writing. So the ionic bonds are always between columns 1, 2, 3, groups 1, 2, 3, over here, and groups 16, 17, 18, 16, 17 over here. But covalent bonds are between the nonmetals. So you have carbon dioxide. That would be a nonmetal. I'm sorry, a covalent bond. I'm tired. Okay. So one major clue for working on covalent or ionic is, does it conduct electricity in solution? Ionic compounds come apart, dissolve, or disassociate, we say, in water. Ionic compounds come apart in water. And so if I have a block of salt, I have positives and negatives all kind of lined up together in this nice little matrix pattern where the positives are attracted to the negatives. And we have it held together in a nice little block of solid salt there. Then I take my block of salt and I put it in a beaker with some water, and what I get then are a whole bunch of NAs and CLs, not in any sort of pattern or arrangement, but just kind of floating around, however it makes them feel good. And I'm not drawing this terribly randomly, but that's what it is. Just kind of a random collection of NAs and CLs as individual ions. This is going to conduct electricity because we have all of those ions to carry the electric flow. Where for covalent bonds, the covalent compounds, I'm going to use sugar as my example here, they stay bonded in solution. They stay as their compound when you put them in water. So here's my sugar crystal, my cube of sugar. Sugar is C6H12O6, and it is just 1 molecule on top of another molecule stacked together. And when I put this into water, this is my beaker of water, I still have all of my C6H12O6s all bonded together still in the water. And this does not conduct electricity because there's no ions. Does not conduct electricity because we are not talking about ions. Okay, when you come tomorrow, you're going to get this assignment. I swear, here we go. This assignment. And you are going to start building covalent bonds. So it has a data table. We've talked about this a lot before. How many protons, how many electrons, number of valence electrons it wants to fill. But you'll notice that all the elements we're dealing with here are nonmetals. So to do a covalent bond, you've got to talk about sharing. And I'm going to do one for you here. I'm going to do the hydrogen one. And it's the easiest one, which is why I'm going to do it. So what we have here, we have hydrogen. I've got two of them. And each hydrogen, since it's in the first group, since it's in the first column of the periodic table, I know it has one valence electron. And I have two of those, so there's a valence electron from that hydrogen. And then here's another hydrogen with its one valence electron. So if they were to share that, they would have two in between them. So I'm going to draw them sharing those two electrons. Now what I'm going to do is I'm going to show that that hydrogen has access to those electrons by drawing a circle around it and the electrons. And I'm going to show that that hydrogen has access to them as well. That is allowing them to share. What I'm going to do next then is, since they are sharing just one pair of electrons, I can draw this another way. I can say this hydrogen is bonded to that hydrogen. So that would be like a bond diagram, where this dashed line here is representing that shared pair of electrons. And I can also write it as a formula, which is H2. So you have half a dozen of these where you're going to show the original Lewis dot diagrams, you're going to show the covalent bonding, you're going to show the bond diagram, and the formula. See you tomorrow.